Now what we want to look at is how we use significant figures in calculations. Anytime we're dealing with any kind of measurements, we always have to be worried about significant figures. So it's one thing to look at the numbers and say, yes, this measurement has 3 significant figures or 4, whatever the case may be. But we also have to deal with that in calculations. And we're actually going to talk about 2 different sets of rules, one for addition and subtraction and one for looking at multiplication and division. So 2 different sets of rules for those. So first we're going to look at addition and subtraction. And what we do is we say, well, the answer is based on the least number of decimal places, not necessarily the least number of significant figures. So here we have 1.2 plus 3.31. Now what I get here, this number, 4.51, that's my calculator answer, and that's fine if I'm just dealing with a number. But what I'm worried about is that these are measurements. And because they're measurements, I cannot add precision to the answer that was not present in all of the values that went into that. So I have to round this to the least number of decimal places. So we have 4.5 there. Now I want to look at multiplication and division. And in this case, our answer is based on the least number of significant figures. So here we take our same numbers, but now we're multiplying them instead of adding them. So we have 1.2 times 3.31. And if I were to look on the calculator, what I would see is 3.972. That's the mathematical answer. But I need the scientific answer because, again, we're basing this on measurements, and so we cannot add precision to those numbers. And so what I look at is I see, well, this value has 2 sig figs, and 3.31 has 3 sig figs, so that means my answer can only have 2 sig figs. So I take what I found on the calculator and I look and see that I only need to keep these first 2 digits, okay, because those are the ones that are actually significant, and I'm going to round based on this first digit that I drop, and I end up with 4.0. So now my answer is not more precise than my least precise number that went into that calculation. There are some numbers that are called exact numbers that we do not have to look at when we're determining the number of sig figs for our answer. And exact numbers are those obtained by counting, such as 8 people, 6 eggs. There's no half a person or a third of a person. It's exactly 8 people. So we ignore those numbers when counting sig figs. The other thing is that when we have 2 units in the same measuring system, so 1 quart is exactly 4 cups. That's its definition, and those are exact numbers. 1 kilogram is 1,000 grams. Again, exact numbers. We don't look at those. 1 foot, 12 inches, and there are others. Now, there's one that's a little bit trickier to see, and we don't usually think this is an exact number, but the definition of an inch is exactly 2.54 centimeters. So we actually won't use these values in determining the number of sig figs. Most of the time when we're dealing with conversions between, say, the English and the metric system, those values are not exact. This is one key exception. It is an exact number, so it is not going to determine the number of sig figs in our answer. So what do we do when we're rounding off? Well, we are always going to have to round to the correct number of significant figures. So what we look at is the last digit that we want to keep. So we're looking at this problem, say we want to keep 4 sig figs. That means this 2 is the last number I want to keep. So I have to look at the 1 and only that 1 there to determine whether I round up or round down. And because that 1 is a number less than 5, I'm going to round that to 3.402. It does not matter what digits come after that. I only look at that first digit to be dropped to determine whether to round up or down. Likewise, if I go to this next example, 10.3911, and I want to have this with 3 sig figs, then I see that the 3 is the last number I'm keeping. The 9 is the first number that's going to be dropped, so it's the 9 only that determines whether or not the value gets rounded up or down. And because 9 is 5 or greater, I'm going to round that up to 10.4. So when you're going through calculations, sometimes you have multiple steps in a problem. Now, sometimes you leave that number kind of saved in your calculator and continue on, and that's fine. If you're writing numbers down, what I recommend is to keep one extra digit and then round to the correct number at the end. If we round too soon, sometimes we can start to lose a little bit of accuracy in our answer. So it's always to keep it good to keep at least one extra digit. But if you keep them all because you're saving it in your calculator, that's perfectly fine as well. Now let's look at an example where we're adding some numbers together. So our original problem was written up here, and I've rewritten this in a little bit different format so it's easier to see what we're going to be canceling out. And what I look at is that I'm going to have my values here all lined up at the decimal point. If I add this all up on the calculator, this is the value I'm going to get. This is my mathematical answer. And what I can do for adding these numbers is I can look at these numbers and find where do I have the least number of decimal places. And I'm basically going to be drawing a line down through there. And now that I see what I've got, my answer is going to be 34.22 as my answer because I only need to keep 2 decimal places. And when I look at the first number to be dropped, it's a 3. So that tells me I'm going to round down, and so I get my answer of 34.22.